Thank you so much, everybody, for coming to my talk. I know you have other choices and for you to choose my talk, so thank you very much. And as such, I'm going to be talking about event streaming in a cloud-native world, and then specifically, too, I'll be sharing with you something about Apache Pulsar. Let me first ask you, how many of you have heard of Apache Pulsar? Yeah, so quite a lot of you, but how many of you are already working with Pulsar? Maybe? Not yet, right? How about Kafka? Yeah, okay. Thank you. I think that's usually the responses I've been getting at a lot of places these days. I think a lot of folks like yourselves are using Kafka as your distributed messaging broker in your environment. But I like to talk about Pulsar too, why you want to choose Pulsar. But also the exciting thing is really about event streaming. And I also actually have a talk too about Apache Pulsar and Apache Kafka working together. And I'll just share a bit of information with you about that too. So without further ado, I'm going to start now, and let me go to this slide, which is actually, if you're interested in this slide deck at this point, you can get to it here using this bit.ly link or the QR code. I will be sharing this slide deck too with the organizers. So even if you miss it now, don't worry about it. It will be available to you. So, okay, I'll just give a second just to make sure you get it. And okay. All right, as folks are still coming in, I just want to point out too, I have some stickers too about Pulsar and also from DataStax. So if you're interested in it, after the talk, you can come up here and get them. Maybe I'll just move it closer so you don't need to actually walk up here to get it too. So, okay. So that's that. I think there are folks settling down. So I'm going to start just introducing myself first. My name is Mary Grygleski, as staff has already introduced me to. And I spoke at Vox Days Thessaloniki last year. So maybe if you were there, thank you if you come again too. I think there's only a few of you here. So I spoke actually also on a similar topic. But after a year or two, I have gathered more insights into this topic. So I hope to make it a bit more informative for you as well if you heard me before talking about this topic. So, okay, so I'm a developer advocate at DataStax, which is a company that's more well-known for their Apache Cassandra platform. And we also have a managed cloud. Basically, we're a database as a service and now moving into event streaming as a service. And also, just 2 months ago, the company acquired a company called Cascada. It's a small startup company based in the US, and they make machine learning features, specifically like feature store engine and feature store repository towards that end. So company are now kind of more like talking about it as like a data in all aspects of the company. However, we're here today to talk about technology. I'm not trying to sell you anything. I'm not a salesperson, and I understand that. But that's my company or the company I work for. And then previously, I was with IBM as a developer advocate in the Java space, so doing Java open source, a lot of the Jakarta EE, some Jakarta EE. Actually, I see Ivar in here too. So from the Jakarta EE group, so also. Some other like open source like MicroProfile or Open Liberty as well. And then prior to me becoming an advocate, I was spending like 25 years or more as an engineer. So I understand too, a lot of you probably come from like engineering background or that's what you're doing now as developers. So I can certainly understand to what it is like, right? The day-to-day, a lot of stress and you have to do a lot of things is that type of stuff. But I kind of became interested in becoming a speaker, also involving with user group. So I'm also the president of the Chicago Java Users Group and also a Java champion too. So that's a bit about me. I'll move on. This is just another diagram or pictorially describing myself and also how you can get a hold of me, but I'll share the information with you again towards the end too. And today's agenda, I'll be first talking about giving you a bit of a background because assuming maybe not everybody coming in here are familiar with events, all aspects of event computing. So I'd like to give a bit of background, so bear with me. And I know I don't have really way too much time, so I may be moving a little fast there. Just some of the basic concepts first and the semantics of event messaging. Then now getting into talking about event streaming, why do you want that? And also eventually talking about Apache Pulsar, that's the meat of this talk. And also showing you a bit too of from DataStax, if you want to quickly try out Apache Pulsar, you can actually use our managed cloud platform and get free credit for trying out too. So that's the plan. So first of all, let's talk about the many facets of computing, like events. So it's kind of an exciting area. So I'd like to kind of first point out, right, about event computing and what is event, right? Just to first start out with, kind of going back to the basics about like an atom, you know, in all matters. But in this case, it's about event. So event is really a point in, it's essentially space and time, like a happening. But that happening is being captured in 4 dimensions. Then there are 3 dimensions, there are 3-dimensional space, right, X, Y, Z coordinate, and also the time component. So it makes it quite interesting to do this kind of work. And a lot of times maybe we just do things without thinking, but I like to think that, okay, this is about events. We are having events every day, events that are very natural to our human being, you know, living condition. We are living in an event-driven world, you know. So, but then, however, when we started learning computer programming, I bet a lot of us, right, most of us, or almost all of us, started learning to program in like the traditional way, which is more synchronous style of programming. You are kind of simplifying the world around us, kind of flattening it, and also not about events. It's more about synchronization. Everything is like about request and then response. So you have a request that comes, then you process it in a blocking manner. When it's done, then you receive the response. However, that doesn't mimic the real world. And I think that's where a lot of computing issues, not really like issues, but it's just that as the world is going faster and faster, we do need better ways of, you know, addressing this. And in computers too, we live, you know, with technology everywhere now. So we need to like update all of our technical capability, and event streaming is basically the way for us to all go towards, because it supports like primarily like real-time processing, all of these things. So that's about events. So let's kind of move on to the next one. And as we I just wanted to kind of quickly point out, won't go into all the details. A lot of times I'm finding is that, you know, the term event computing, event streaming, event processing, all of these, as you can see over here, event-driven architecture, and what else, like even event storming, event sourcing, all of these, yes, they are kind of dealing with the event-driven, event approach of computing. And can be confusing, but I just want to lay them out here. This is in the talk to kind of discuss each aspect, but just want to lay them out here to make you aware if you are newer to this aspect of computing. And they're fascinating too, because they really are the way to go. Again, you know, for kind of mimicking the real life situation. And again, you know, like all of these messaging streaming is what we're going to talk about today. But then I also want to bring up too, there are microservices that are higher level of kind of abstract kind of concept, in which is leveraging on event messaging a lot. Because of the way how event messaging, event way of computing, is that you decoupled all of the components. So a lot of times too, with that approach is really, you know, the right way mechanism to be used by, let's say, serverless apps, microservices, and reactive systems. So these are just terms that I'm laying out here. And as you can tell, there's also one note I like to point out. There's also event storming, and I find that it's a bit of confusion in there too. Event storming is more about the domain-driven design way of doing like requirements gathering with all of your stakeholders, like a functional gathering of, you know, or functional requirements brainstorming, you know, pull together all of your stakeholders. So that's that. So yeah, so again, this is just an introduction to these terms first. But now let's get into event streaming and processing. So again, event points out to one, you know, if you kind of think of it, it's just a point, you know, that happens. And if it happens, you cannot change it. It's immutable. It's there. Now, the thing is, by itself, it doesn't make much, you know, won't do much. It carries with it some data. But what makes it interesting is that you have a series of events, you know, that happens through space and time. So you can plot that thing on a graph, right? All of these data points in time and space. And that actually is the stream. It's an ongoing delivery of that event. So that's event stream, right? And it's ongoing delivery. And a series of all of these events together is basically like streaming data or data streams. One thing I like to point out is that I got asked too about whether Apache Pulsar, can you use it for video streaming, music streaming, all of these, right, that we're so used to today. About, we go home, we watch a movie, let's watch it on Netflix, it's all streaming. That's all streaming too, and we listen to music like all these streaming. Yes, it is also about, data kind of flowing through space and time, but yet with video, audio, all of these video or kind of media streaming, these are not what we are using Apache Pulsar or Kafka for, because those kind of streaming requires a certain level of synchronization, right? As you can see, right, we're watching movie, all of these data coming in, we need to make sure they occur, when you deliver it to your end user, they need to happen in the right order. Very important. Otherwise, if you're listening to a piece of music, all of the data frames that comes in, if you're out of sync, you won't be listening to the music that you're expecting it to, right? Or watching a movie in the right sequence. So just want to kind of point out to the event streaming we're talking today is really for a more data processing kind of aspect of streaming. And then now we move on to talking about complex event processing. So again, just now I talk about streaming, but there's also the processing aspect in which you first ingest all of these data in, right? That's more streaming. And then basically by itself, all of these data won't make sense unless you do something about it. And that's the stage when you pull it into is basically the processing aspect. You need to do some analysis on the data and make it useful, right? And what is useful today, especially now we're living in a world that's full of amazing things now. For example, ChatGPT, right? All of these AI, machine learning, all of these, right? And they require a huge amounts of data that comes in and also needs to have a very quick kind of way of being able to get the data immediately and then process it. So that's kind of complex event processing. It's basically capturing all of these data, analyzing these streams of data and making sense out of it. So for example, like using event streaming would be, one example would be using it in fraud detection system. Like say, for example, your financial bank accounts, that's important. You need to have some process in there to constantly be monitoring all of your bank accounts, your investment accounts, and making sure that there isn't any suspicious activities going on that would drain your account, right? So if something goes on that isn't correct, then the system need to be able to respond to it quickly and notify the account holder, letting them know, oh, you kind of got some money debited from your account here in, let's say we're in Greece here, and all of a sudden you get it debited somewhere in South America or something, then that system needs to be able to notify you and say, oh, some suspicious activities. So that's an example of a fraud detection system able to make use of event streaming platform. Other things, for example, like in retail, for example, like your order entry, you're doing online shopping. These two, you are constantly monitoring like keystrokes of your user on your website that is shopping. So once you kind of get the data, you have to be really fast. You immediately want to analyze the shopping patterns or what they are shopping, and then you immediately derive, maybe use some AI type of algorithms, right, to kind of analyze to see, okay, I'm trying to shop for a car, and then I want to immediately search for a similar car model and suggest it to the user. That type of scenario you can think of using event streaming. So those are kind of example, and also what it is about complex event processing. And now let's kind of get back a little bit into basics in which we're talking about messaging. Messaging, to me too, is that I look at it like, okay, it is tightly tied into streaming, but not exactly, because messaging is more about a sender, involves the actual, more like the point A to point B type of messaging. Kind of sending and receiving. So that's messaging. But there are also some subtle differences. There's one about event-driven messaging, and then also message-driven messaging. Now, this interpretation is what I took from the Lightband, the company that makes Scala, and also the actor ACA, the reactive systems. So because they are the ones that leads the reactive manifesto, reactive foundation movement, right? All these reactive programming, reactive systems. So they have a really nice explanation. So event-driven messaging is really about, yes, you're sending data from point A to point B. But the difference is that your sender doesn't have to worry about the address of the receiver. So the sender, producer, or publisher, how we call it, pub/sub or producer, producer consumer kind of pattern is a pattern in which your producer will send the messages, admits the messages, and it's basically label it, right? Kind of call it a topic, or kind of in microprofiles term, we call it a channel, something. So a way of telling it how to route your messages. So that's kind of publisher. Publish, subscribe. And the subscribe side will be the subscriber only receive the messages that matter to him or her. So you only subscribe to topics of your interest. So that's kind of the differences is that, your senders keep sending messages, many things. It doesn't matter. I just send it and label it a topic. And then let the agent take care of it. And very often, this is what is called a broker. In Kafka, kind of the pattern, it uses pub/sub, there's broker. So is like Pulsar too. We have a broker that basically in the middle handles, receiving the messages from producer and then distributing to subscriber. So that's kind of event-driven way of messaging. The other way is basically message-driven. So in that case, is your point A to send to point B, or sender receiver. The sender and receiver have to know kind of each other in some ways, because you're actually dealing, very often we describe this as a message queue. You'll be sending messages to a known address, the known queue. And then basically receiver will need to pick up the messages from the queue. And once the messages get picked up, then the message will be gone. And that's the idea. So, but they both too, as you can see, pub/sub, event-driven messaging and message-driven, like in a queuing, it's very fast. And also it decouples the sender and the receiver. So makes it even much faster too in this case. So that's the advantage. Okay, and then one more point I'd like to point out is that besides doing like event, like basically event-driven type of processing, all this messaging isn't new, as we know. But the thing is that it's kind of becoming more of the primary concern of today's kind of fast-paced world. Now, in the old days too, it's not too old actually, and we're still using, if you don't use the event way, then it will be called batch processing. And then that case will be all of your data changes that are happening during the day will be collected, during the day, and you don't process it until at some point, maybe at night, or when your system is free. So the idea is that you batch up all of these things and then processing them at a later point in time. That way you free up too. A lot of times if you're doing more immediate kind of processing, it involves a lot more networking going on. You need to send in a distributed environment. You need to send data from here to there, all of these things. So the thing is with batch processing, you just collect all of the data and then at a certain point in time, you can process them. So for example, like system of record, like your employee system at a company, those are not urgent kind of data, so you can wait. So all of these changes that occur during the day, you collect them. And then at that point, you can, at the end of the day, you collect all of the set of changes, then you process them later. So that's more like, kind of they juxtapose each other. They each have their space, in the world, basically. You need to pick the right tool for the right job is what you should be doing. Okay, so now let's get into some semantics and patterns. And I already talked about pub/sub, right? It's more event-driven messaging, kind of making use of that. When we talk about streaming, very often we're talking about the pub/sub pattern. It's basically an architectural pattern, and it doesn't dictate how actually you implement it. How it implements it depends on the vendor. But very often, when you have to do pub/sub way of doing things, and that's the idea, is that you have a broker in between. And basically, again, you have producers that are producing messages to a topic or some kind of label. You label the messages, and then its broker will own the topics and then deliver the messages accordingly. And then on the subscriber side, you can have many subscribers to one topic or to many topics or just dedicated, all these things. And basically, subscriber will only subscribe to the topics of interest to him or her, kind of like that. So that's the idea, is a streaming and pub/sub type of semantics. And again, here is about a semantic is on message queuing. So it's like making use of the first in, first out principle, FIFO, right, kind of way of doing things. So sender will send messages to the queue. And then as you can see, first in, first out, they get picked up in the sequences being entered into the queue. And basically receiver will pick up the messages like dequeuing, right? And so the idea, again, right, it's really for asynchronous type of processing and very often being used in microservices type of architectures and serverless type of applications too. Again, it decouples heavyweight processing and kind of helps, to kind of oftentimes it's kind of lighten up all of these spiky workloads too. So both are kind of the similar thing is that between the two PubSub and message queuing is that it's very much decoupled kind of all of your components and also very fast. It allows for a synchronous style of processing. Okay, so now then let's get into a bit of event, step beyond just messaging will be the event streaming part. I think I will just very quickly go over, we already know, is basically we want to process data in real time or close to real time. And that's why we want to pick an event streaming type of platform to do it, right? Because it's got benefits to everybody too using it. Every time in today's world, we want everything to happen right away. So that, using this messaging style, kind of driven type of systems, you can achieve the real-time kind of effect. And also, you can use that, for data pipelines that are kind of catered for artificial intelligence or machine learning type of purposes. As you know, data or AI and machine learning systems require really fast, and it trains the data as you receive the data. So this, kind of using an event streaming platform is kind of being suggested that you should be doing instead of, a lot of times my understanding is that maybe sometimes some of the AI system has to deal with so much data that currently, maybe the event streaming platforms are not able to handle yet. So they are still doing like batch processing. But the idea is that eventually these event streaming platforms should be able to handle data in huge volumes, like in like, I don't know, like terabytes of data, something like that. And so the idea is that you want to be able to, have the data come in and process them in real time, and immediately you want to train your model and deploy the model back, right? So it's a fast cycle. So that's what you can think of using event streaming for, as well as in other cases will be like for scalability purposes. For example, like IoT type of applications, you can be collecting data in a field and many devices that are scattered in the fields, and basically any kind, you have temperature changes, you have to immediately send all your data from your sensors to the servers, that type of stuff. So basically, in like scalability, if your systems is, you're expecting kind of heavy spikes and up and down, that would be also a good candidate to use event streaming. So this one is just, again, summarizes what we just talked about. Basically, you watch for events with the system or application and subscribe. On the consumer side, you subscribe to topics that matter to you. And then this helps you to make decisions in real time to no longer to have to wait for the data to come. And not only that, you can basically ingest data in high volumes too. Like in all these streams, it can come all at once. This one slide, I just want to explain to you what, kind of comparing. Basically, in the old days, right, the one below, when you're not using a real modern day streaming platform, for example, like ETL system, extract, transform, load, and those are actually, what they do is you ingest data first, you load all the data, but very often too, you have to persist the data to a database or some storage. And then from there, you select the data and then do further processing, and then you write it back to disk again or to a database. So as you can see, it takes up extra time because that involves like disk I/O. However, with modern day streaming type of platform up there, you ingest the data, and after you ingest it, you are processing all of the data in memory. You don't even kind of touch the disk. And so it makes it even faster in that case. And then when you are done processing, basically there are usually some transformer or library in between. For example, like Pulsar, there's Pulsar functions. You can transform them and then write the data to a sink. That's where you kind of write your destination data to. Everything happening in memory, so much faster, and then you can do processing right there. And the idea too is that it allows you to build data pipelines, so to speak, right? Your sink can become another source for another pipeline too, so on and so forth. So think of it like Lego pieces. You can have data pipeline, from some old mainframe systems that you want to generate some data to, like maybe send it to a topic. You get the data and then you process it, you further send them downstream to another systems like that. So that's the idea. Okay, so now let me introduce Pulsar. So Pulsar, basically, it's started by Yahoo Engineering. That was back in like about 2013, around that time frame. They were using the Yahoo Engineering they were using Kafka. Then they realized that Kafka is just not as easy, right, to operate in the cloud. I mean, the thing is, if you have defined all your consumer groups, all of these things, it's easy enough. But if your system doesn't grow, it's fine. However, in today's world, right, your systems can grow, your data structure has to change to meet the needs. Then every time you need to change, right, then you have to recalculate all of your topics, your consumer groups, all your partitions. It becomes kind of not very easy to do. So Yahoo decided, well, let's write a system that will kind of, overcome all of these shortcomings of Kafka that, kind of basically require developers to have to worry about. So that's why they developed Pulsar. And very soon, in 2016, they donated it to Apache Software Foundation. Then in 2018, that became a high-level or top-level project. So folks are all recognizing its kind of usefulness and kind of potential. And so Pulsar itself is actually being designed in a very cloud-native way, right? So it has the cloud-native design, and it's all cluster-based. So natively, it's already cluster-based. Also, it has what is called like multi-tenancy. So that helps you in terms of organizing naturally, right? The messages, you can organize them according to different tenants. So say, for example, you are a service provider, you can have different companies that you are hosting in your cluster, same cluster, and then you want to divide off all of the messages. It's already, if you use Pulsar, it's already naturally divided up into different tenants. You can basically set up your Pulsar streams, all of these things according to different tenants. And even within the tenants, you can have kind of subtrees, so to speak, different namespaces and organizing all of your messages. So that's a really nice feature to have. Also, Pulsar, allows for, it has a very simple, not very complicated client API, the many client bindings too. That includes, primarily if you're a Java developer, you can write in Java, writing your producer or consumer in Java code, or also C#. And so in other words, .NET, we also support, as the client connecting to it. Python and Go, and also other community contributions, such as like Scala, Rust, the other ones like Visual Basic and C++, all of these are all supported too. And also another feature too, I feel, is about Pulsar being kind of different and also very useful is the fact that it separates out the compute and the storage. As we know, we're dealing with distributed messaging systems, so messages comes in, it almost feels like a laundry basket, right? For example, we just like have clothes, we change out, we have to take care of laundry. So it's basically Pulsar said, I don't want to do all the laundry, so let me have somebody do it, and that's Apache Bookkeeper. So Bookkeeper as such, is a project, a library, right? That's sophisticated in handling all of these data as though they are kind of like ledgers. I think if you're familiar with accounting. So it has fast read and fast write type of way of doing things. So that's Bookkeeper. So basically, Pulsar said, I'm not going to deal with all these log messages, but I'll have Bookkeeper do it, but I'll communicate. The broker will communicate with the bookkeeper about it. So in this case, as you can see, then it makes it kind of easier in terms of scalability. If you need to scale in your cloud environment, then it's easier because then Pulsar itself only handles all of the messages. It's easier to kind of grow that, right? Your broker may be partitioned off into different cluster, different nodes, and you can scale it. You add a node or subtract a node. All of these, scaling it is relatively simple. You don't have to kind of drag along, okay, the bookkeeper side, because bookkeeper keeps track of all of the log messages separately. Also segment them, all of them off too. So that's the idea. Okay, and then the third thing is basically about message delivery. As we know, that's very important too in messaging systems. You're sending your messages and it's all asynchronous, but how do you guarantee, right? So in that case, you guarantee, basically in Pulsar is that you send your messages, once it's received by the broker, then you're safe. Basically, if something goes down, your node goes down, your broker is gone, don't worry about it, it's already in the system, then Pulsar has the mechanism that will know that you already sent the messages, I'll guarantee the messages gets delivered. Another feature about Pulsar is the serverless functions framework. So as I described about data pipelines, you have your source of data coming in, and then basically you want to, very often, you do need to do some transformation of your data. Maybe you need to add something to it or filter the messages or do some like lookup to your, your database or something, right? It could be passing in a bunch of messages with some ID. All of these things, well, the ID you need to look up. So you can basically make use of the Pulsar functions framework, so without using anything outside of this platform. Pulsar functions allow you to do these simpler kind of transformation kind of functionality. And also, too, at DataStax, we have like transform functions. These are pre-configured functions that are more commonly used functions so that you don't even need to write those code. Things such as like filter, certain types of filtering, certain types of like casting, all of these operations are already pre-configured transform functions. Otherwise, too, you can write your own custom functions, too, and then deploy onto the platform, and our platform will take care of, kind of taking care of it running in the cloud-native cluster, too. And then one more kind of special feature of Pulsar is that it has a tiered storage offloads. What it means is that, a lot of times, as we know, messages comes through a system, and there are tons of it, and then sometimes, too, the messages gets cold, right? It's inactive. So it's taking up space. And in a public cloud situation, you get charged, for how long you sit on your disk or something, right, in the main storage. And so Pulsar, it's already built in. It knows about some of these inactive cold messages. It will move it to offline storage, such as like S3 buckets. And Hadoop has file system, all these things that are cheaper storage too. So you can configure Pulsar to take care of things like that for you. So as you can see, Pulsar is just kind of built, kind of for that kind of like helping you to operate in the cloud native kind of environment and making your life much easier. Let's put it that way. So. Okay, and then this too is just a quick slide showing you the number of GitHub stars, number of contributors, and it's kind of all rising in there. And also in 2021, and Apache Pulsar is one of the top 10 projects with ASF too. So it's gaining in popularity. And these are just some of the companies, just a small handful. There are increasingly many companies are looking into Pulsar as well, from all over the world too. But Yahoo is still using it very heavily too. Okay, and how is Pulsar different? Maybe I'll just be real quick in here, just talk about. But first of all, to just the Pulsar components, just to have a quick review, you write the code, you write producer and consumer code, and broker itself is a serverless Java JVM process running. But in a very typical scenario, in a Pulsar cluster, you have multiple brokers too. They are all partitioned, in your environment too. So multiple ones will increase the throughput of these things. And broker also is the one that communicates with the bookkeeper. Bookkeeper, again, is the persistent message store, handles all of these. And also it makes use of Zookeeper. Zookeeper is there to help with the metadata cluster, all of these things. It handles all of these coordination, kind of more high level, kind of, again, keeping everything kind of in sync. So that's the idea. Okay, this one I probably won't go into all the details. I realize is kind of running a bit out of time, but just again too, it's just the diagram showing you conceptually what it looks like. Producer, consumer interacts with the broker. As you can see, broker is kind of the middle, kind of important one that handles serving all of these messages and communicating with the bookie. Bookie is basically an independent unit of operation in bookkeeper. So you very often you have multiple copies of bookkeeper, the bookies running in your typical cluster too. Okay, and then this one, just wanted to point out to you too, Apache Pulsar, you can think of it more like a bolt-on. It's a very friendly type of event messaging hub. Let's say you already have Kafka running, or you have older JMS systems running, or RabbitMQ. You basically can keep those running, and then just use Pulsar as the messaging hub. And so as such, right, it's really ideal for doing PubSub, for doing streaming, queuing, and message mediation and enrichment through the use of Pulsar functions. So, and then at the DataStax too, we actually have free, like a Starlight API layer that allows you to talk natively to Kafka, JMS, or RabbitMQ as well. So those are all open source, and you can just take them. And I've shared all the links for you to kind of take a look at and try it out too. Okay. And this one too is just another diagram showing you it's like Pulsar is a unifying type of platform. And if in a company, typical in big company, you can have multiple systems. And a lot of times, right, you can have many, different teams that are running different things. You can be running some database systems or messaging systems, or you're doing programming, all of these servers that you're doing, you all using different types of tools and libraries. But you can use Pulsar as like the middle kind of messaging hub too, so to speak. So as you can see, it's a very flexible event streaming platform. Okay, let me see this one. Let me go to the next one. This one, okay, so maybe I won't have time to kind of go into details, but want to quickly point out, to summarize, key differentiator is that Pulsar will separate out the compute and the storage. Storage is handled by Apache Bookkeeper. So basically, then in this case, if you need to scale the whole platform, it's easier too. And then another feature about Pulsar is this geo-replication feature, like usually in big companies or even not too big. You can have like multiple data center, right? That's kind of running in different regions, or even within the same country, you can have different city centers. So all of these, they are different independent operating kind of, cluster. But the thing is with Pulsar is that it supports like geo-replication quite easily. So systems can continue to run. You can do replication. It does it for you. Also, it helps you to do like message replication, or selective message replication. So let's say if some data you don't want to necessarily replicate them all over, you can also configure them too. So that's already kind of built in. So just want to quickly point out. And then another feature, I talked about it earlier, is the multi-tenancy aspect. So as you can see, you can have a cluster. You can organize your data according to different tenants too. So kind of makes it quite easy, out of the box. So then you don't need to worry about, segregating all of these messages. It's basically pretty native to Pulsar. And then one more thing is about the message modeling processing model. This side, we're dealing with the subscription side. So as you can see, you can actually, by default, is an exclusive mode, which means you only allow for one consumer per subscription. So effectively, turning Pulsar into a queue, a message queue too. It's like one producer, one consumer. Think of it like that. But the thing is, you can also use another mode called failover. In that case, you can specify more than one consumers, but only one is the primary. If the primary goes away, then some secondary one will take over. And then the third one is a shared subscription. In this case, you can have multiple consumers in this subscription, but the message delivery, it isn't guaranteed for the message order. If you want the message ordering or the message packets to be delivered in the order it was received from the other end, and then you can use key shared. In that case, then the key share will guarantee your message delivery is in the order as it was received. So these are like 4 different modes that it supports. And also, just want to point out, I believe Kafka doesn't have that key share type of mode too. So Pulsar has that already built in. And this one, I'm just going to quickly go over real quick about the special features of Pulsar. First, data pipeline. I talk about, look at data as like water flowing through the pipeline. And you flowing through some way in the middle there is where Pulsar function comes in. You can do all sorts of ways to transform all of your water or the data. Then it outputs all the data to a sink. So that's the idea of a data pipeline. And basically, I already talked about Pulsar functions. So Pulsar functions is lightweight. It's much like AWS Lambdas and Google functions. And currently, we're only supporting Java, Python, and Go. But then there are more effort of making it available for other languages too. So that's Pulsar functions, and there's also Pulsar schema. So if you don't specify your schema, any kind of, your message payload, it's basically expecting you to write in byte array. So it's kind of not as convenient. What if you have message payload that's kind of, you want to describe in JSON or describe it using FROW, right? All these like key value pair or primitive types. So you can actually think of using Pulsar schema. So let Pulsar manage the change of your data payload too. So that's also another nice feature in there for you to do, serialization and deserialization for transferring data over the wire. One more thing is about Pulsar I/O. So basically, about data pipeline, you can have different source connector and sink connectors, right? And currently, we support like hundreds of them. So Pulsar I/O is basically allows you to write connectors for those connectors that are not already configured. And so right now, let's say, if I have very typical, say Cassandra, we have Cassandra source, and this already has built-in connector you can use. And let's say we do Pulsar functions, kind of transform it, then we want to output it to an Elasticsearch sink, right? So it's already pre-configured. But if you have something, that you have, let's say proprietary system, you want to have connector to it, you can also build it using the Pulsar I/O SDK too. So that's a kind of convenience. And this one is basically real quickly going over is data stacks. We have Astra streaming. and Luna Streaming, and then open source if you want to try out Pulsar. So Astra Streaming is our cloud platform that you can use and sign up for a free account that you can use $25 per month, and we don't ask you for credit card. So it's already in this slide that I give you the link to. And then also there's Luna Streaming if you want to deploy your own without using our managed cloud platform. So you can use it for free or buy, and also buy our support if you want. And then you can, of course, always use the open source version. This one is basically, I already talked about, there's Pulsar native, or using the Starlight to communicate with Kafka and JMS or RabbitMQ. And then this basically is a diagram showing you all of the connectors and clients that we currently support. So as you can see, we kind of broad category of like databases. There are tons of databases we support as connectors. And then messaging, including Kafka, is supported, and language clients, monitoring, and then software as a service too. So there are a number of connectors are increasing every day. If you don't find anything here, use the Pulsar IO SDK to write your own too. Okay, so now I don't know if I have a minute or so. Let me real quickly maybe show you. I know I'm kind of running out of time, but just wanted to show you the Astra Streaming. This one, if you go to astra.datastacks.com, you can get this, and then you can sign up real quickly if you do go to sign up. And basically, okay, thank you. Okay, I just spent like 3 more minutes, thank you. So over here, if you haven't already got an account, you can sign up using your email, sign up is over here, and it will just ask you for your name and email and then password, then you get an account. No need to give your credit card number. And also you get $25 US dollar per month to try things out too. Now let's say I already have an account. Once you sign up, right, it's there, and then I can just say sign in with Google, my Google account, and okay. It's a little bit, it's taking a bit of time. I won't take too long. And so this gives you, the Astra platform from DataStax. And if you want to play around with database without Cassandra, you can do that too. But today we're talking about streaming. So let's go to streaming. But first of all, because I have many different things, so I actually create different organizations to organize all of my different, my databases and streaming. So I have one called Gits, for example. And this here, I can go to my streaming, and I already have created some tenants. So if you want to create one, for example, you can just say create tenant over here, and then you create your tenant. It's essentially setting up your Pulsar stream. Pick the cloud, and we support Google Cloud, Amazon AWS, and Microsoft Azure. These are the 3. And then select a region, and then you are good to go, right? And I'm not going to create one now, but since I already created. So let's say I just do this Nick, for example. This one's already created. So as you can see, if you come into here, it actually guides you too. It's not quite a full-blown like UI tool, but then it's good enough to guide you through how you can use Astra Streaming. It's basically Apache Pulsar underneath the hood, right? Quick start, you can look, into details. In the details here, that's how you can get information on like the shell, and also your tenant. All of these connection information are there. And then if you want to write code, let's say we're a Java conference here, so let's go to Java. And then you can kind of look into these different tabs of how do you use Maven or Gradle to connect, to build your client code. And there's producer, and I, again, won't step through all of it, but you can kind of take a look. It's relatively simple. If you just do a hello world, it's all in here. Hello world producer and a hello world consumer in here. It's essentially simple as you just set up your client handle, and then with the handle, you basically create your producer, associate with the topic, then you can start sending messages. Likewise, for consumer too, you set up your client handle, kind of set up your consumer, and then associate with the topic where you want to subscribe messages from, and then immediately you will be receiving messages when there are messages on that topic. So that's kind of as simple as that. And then there are examples of how do you use change data capture consumer, as well as there's this thing called reader. So reader interface basically allows you to select and go back in time to look at all of your log messages like programmatically. There's nothing like an offset, or you have to do different things like in Kafka that you need to do in order to look up your old messages. So that's kind of a really nice kind of feature that Pulsar has. So, okay, so I know I'm going over time, and then there are many things you want to still get to. So just want to quickly then share with you some resources. Oh, let me go back. I'm sorry. Let me go back. here, I think this one. So just resources, and these are all the different links, and just the middle one, astra.datastacks.com, is how you can get to the Astra streaming platform and play with the Astra, our Astra Cassandra or Astra Pulsar platform in here. And then these are just different links for different things with DataStax, but the top ones are the ones for the open source. Okay, and then here, oops. I go a little too far. And these are just about community resources and all of the source code listed, including the Starlight for Kafka, RabbitMQ, and JMS, and also DataStax on GitHub, all of our open source projects too. And then also, if you want to have additional credits for your Astra streaming, you can do that too. That's the link where you can connect to and request for additional credits too. And our company will help you if you're a small business, you want to start using Astra too. Okay. And then this is also, we have it on YouTube, some 5 minutes about Pulsar, a short clip too, if you want to follow us on YouTube, on our DataStax developers channel. Also, I have my own Twitch stream, and usually if I'm not traveling on Wednesday, I do some live coding on Twitch as well. And this is our DataStax developers. We developed this awesome Astra site where you can, kind of use it as self-training. We have a lot of materials there too. It's basically a GitHub repo that we share this information. And then this one, if you're interested in comparing Kafka and Pulsar, there's also a link in here. It's the benchmark report from Stream Native. So if you're interested in that benchmark report too. Okay. And here, and I think I've come to the end. And thank you so much again for having come to this. So.